Okay, here we go. Notes on page 13. So it says compare, because we're dealing with stretches and compressions. So we're comparing again to our parent function, the absolute value of x. So this 1/2, when we are less than 1, what it's going to do is it's going to make it wider. Okay, and it's going to compress it towards the x-axis, which we'll get to in a minute. So it says compare. Well, this one is wider. If we come over here, when the numbers are bigger than 1, it just makes it narrower. We come down here. Because it's a negative, it makes it upside down. But again, we are less than 1, so it makes it wider. Here, we are upside down again because of the negative. But this whole number here that's bigger than 1 makes it narrower. So here are our definitions. It says the constant a multiplies the output of the graph by f of x by a. Okay, so that's just this part here. So we're taking your answer and multiplying it by a. So this is kind of the confusing part because it's comparing it to the x-axis. If I was looking at this personally, I would, especially these compressions, I would compare them to the y-axis, but it still gets the same answer. So if we look when it is between 0 and 1, like here, okay, it is a stretch towards the x-axis. So what happens is it gets wider, it stretches closer to the x-axis. When it's greater than 1, it compresses away. So it gets further away from the x-axis. Because up here, these lines are closer to the x-axis than these lines. I don't know if you have to worry about the definitions too much, as long as you just kind of understand when we're less than 1, it goes wider. Here, more than 1, it gets narrower. So again, how did these things be affected? So what is our a in this case? Our a is -2. And that's what makes it upside down. Our h is, remember you have two negatives here, so what you really had going on was x minus a -3. Because of this negative here, this is a part of the equation. And then my k is a +4. And down here, since we went right, we went in the positive direction, and again, because it's negative, just makes that a +5. And we went up 1, and since we got wider here, we had a stretch. So now it says write a function for each graph. So I kind of work backwards on these. So I have f of x, we know that, the function of x. And what do we have going on here? Well, our rise over run is up 1 over 2. So I have 1/2. And then I have the absolute value of x. And in this case, we went over 4 spots. 1, 2, 3, 4. And then we went down 3. So I could go over to Desmos and check that. So I already have entered in 1/2 x minus 4 minus 3. And I can check my vertex for -3. And I can come back and compare that for -3. I went through at 10. I go through at -2. So those are things that I could check. There's that -2. The 10 is right there. So I did a good job there. The other one here, we know that our f of x is upside down because we have an upside down v. But since it goes through at all the corners, it's just 1. There's no stretch or compression with this one. So I have the absolute value of x And now I had to have the two negatives that equal the positive. And we went back 2 spots. So really this is x minus a -2. That -2 is how we get backwards over to here. And then we add 4. Alright, so if you made it to the end of this video, good job. You do not have to turn in pages 13 and 14 as a part of your assignment. That'll tell me that you could follow simple directions, but you do have to upload pages 15 and 16. That is your actual assignment. I think it was reasonable if you just watched this video today. Didn't have a ton of things to write down, but I need to see pages 15 and 16 in your upload. Thank you and have a great day.